Welcome back, PM1 students. Today we're going to look at some exam questions, series exam questions. So looking at both arithmetic and geometric series, as well as binomial expansion from the June series of PM1 examinations from 2021. So the first one here, we've got some first 20 terms of an arithmetic progression is 405. Some of the first 40 terms is 1410. Find the 60th term of the progression. So what I'm going to do here, if the sum of the first 20 is 405, so I'm going to go 405, and remember you've got in your formula sheet the formula for sum of arithmetic series, so it's n over 2, so which is 20 over 2, so 20 over 2. Bracket 2 times a, which we don't know a, plus n minus 1, which is 20 minus 1, 19d, we don't know what d is either. So it looks like we're going to have some sort of simultaneous equation. So we get 10, so 20a, plus 38, plus 190, whoops, d. Now, I guess we can simplify this. Let's simplify it with 5, so 4a plus that's 38, isn't it? 38d, and 405 divided by 5 is 81. So we get 81 here. Okay, so that'll be my first equation. And of course the second one is the sum of the first 40 terms. So we just do 40 terms, so 1410 equals, this time it's 40 over 2, which is 20. Remember your formula, so look at the formula sheet. N over 2 bracket 2a plus n minus 1 times the difference. Okay, so that's what we're using here. And then, of course, that'll be into 2a plus 39d. Now, I guess I could just expand again. So I get 40a plus 780d, I think, is that correct? I think that's right. And then what goes into all of those? 10, obviously. So 141 equals 4a, so 4 up there, plus 78d, and we'll call this our second equation. So I've got 2 here and 1 here. Now we can use simultaneous solution here, so we can go 1, no, let's go 2 minus 1, so we get 141 take away 81. So I think that's 60, and then 4a take away 4a is gone. 78 take away 38 is 40d, so we get 40d here, and so d is equal to 6 over 4 or 3 over 2. And therefore a equals, now we can just substitute that back into the formula, and let's go. So 81 take away 38 times 3 over 2 should give us 4a, so which is 24. Divide that by 4. So I'm getting 6 is what a is, just using substitution there. Okay, now the last bit is find the 60th term. Now the nth term is a plus n minus 1 d. Now we know a is 6. The 60th term is going to be 59 times d, because we've got 59 differences there. Now what do we get when we do this? 94 and a half. Alright, lovely, 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 lovely. Okay, the next one we've got to find the first three terms in this expansion. So this is binomial expansion. So 5, choose 0. 3 to the power of 5. Obviously, negative 2x is to the power of 0. That's the first one. The second one is 5, choose 1. The 3 will be to the power of 4, and the negative 2x will be to the power of 1. The third term is 5, choose 2. 3 is to the power of 3, minus 2x is to the power of 2. Dot, dot, dot. Okay, that's all we needed. So 3 to the power of 5 is 243. Then 5. 3 to the power of 4 is 3, 9, 27, 81. And then we're going to times that by 5. And then we're going to times it by negative 2. And that gives us negative 810x. Now 5 choose 2 is 10 times 3 cubed, which is 27, and then times negative 2 squared, which is timesing it by 4. So that's 1080, and it's positive, so plus 1080 x squared. Okay, those are the first three terms. Hence, find the coefficient of x squared. Okay, so we've got this. And I'm going to just expand this straight away. So if I'm expanding that, let's get rid of that. That would be 16 plus 8x plus x squared. Whoops. And then into what I've just done, which is 243 minus 810x plus 1080x squared. Now I try to find the x squared coefficient. Now the number of ways we can do it. We can do this one times this one. We can do this one times this one. We can do this one times this one. So so 16 times 1080 is 17280. So 17280 x squared plus the next one is actually negative 8 times negative 810, which is negative 6480. Negative 6480 x squared. And then the last one is plus 243 x squared. We add all of those together, and I'm getting 11043 x squared. So therefore, the coefficient is 11043. Alrighty, the next one is 5th, 6th, and 7th terms of a geometric progression are blah, 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 and we've got to find the sum to infinity. Now, the sum to infinity is given on your formula sheet, and it's the first number in the series over 1 minus the rate of difference. Now, if you've got 5th, 6th, and 7th, this is AR4, this is AR5, and this is AR6. Okay? Now, we can go negative 12 over 8, okay, that's R, is equal to 2k over minus 12, which is also R. Okay? So those two things are equal. So then we can go 144 is equal to 16k squared. And therefore, what's 144 divided by 16? Is that 8? No. 9. 9. Okay, yep. So k squared equals 9. We know that k is negative, therefore k is equal to the square root of 9, which is negative 3. Okay, now, if k is 3, therefore a is 8 times negative 3, so negative 24, and therefore the difference equals, how do we go from negative 24 to negative 12? 1/2. Oh, it's not D, sorry, it's R. I'm on a geometric series. What a wally. Okay, there we go, done. Now, then we can chuck those numbers in, so we get negative 12 over 1 minus 1/2, which is going to be hang on a second. Hang on a second. That's not A, is it? I've just realized something. Wakey, wakey. It's not A. This is the fifth term. So A R to the 4 equals negative 24. Okay? So that's not helpful at all. What we can do though is, I guess we can say and negative 12 is AR to the 5. So yeah, so R is equal to 1/2, so that's fine. But now to find out what A is. So AR to the 4 equals negative 24, and A into 1/2 to the power of 4 equals negative 24. And so A equals, well, negative 24 divided by 1 over 2 to the power of 4, and it's giving me negative 384. Wow. Okay, just pay attention to what you've been given, eh? That wasn't A, it was a fifth term. Now that means that negative 384 over 1 minus 1/2 should give us the sum to infinity, which is giving me negative 768 is my final answer. Okay, well, moving on to the June questions from June 1-2 questions from 2021. Right, we've got a coefficient of this expansion is P, and the coefficient of 1 over, so that's the X, and then we've got a coefficient of the 1 over X for this one is Q, and we know that P is Q, 6Q, find the possible values of K. Ooh, 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 ooh. Do not like. Okay, well the first thing is we've got to figure out how we're going to get an X term in this first equation. Okay, so first of all, I don't know what happened there. First of all, your first term is going to be x cubed, and I hope you can see that your next term is going to be x, because it'll be 3 of those and none of those for the first term, and then it will be 2 of these and 1 of those for the next term. So x squared times 1 over x, so that would be x to the power of 1. So we're looking for the second term, which would be 3 choose 1 times 4 to the power of 2 times 10x to the negative 1 to the power of 1. Now the coefficient is going to be p, so we should be able to find out what p is here. So that is 3 times 4 squared times 10, which is 480 x. Therefore, p equals 480. Now, p is equal to 6q. Therefore, 6q equals 480, and q equals 80. Now, what we're going to do is look at this bit now. So we're trying to find the 1 over x. Now how are we going to get that? Well, if we just look at this, the first term is going to be x to the power of 5. The next term, we're going to have 4 of those and 1 of these, so that it'd be x to the power of 2. And I hope you can see, therefore, that the next one is going to be the one we want, which is x to the negative 1. That one there. Okay, so that's 5, choose 2. And then it would be 2x to the power of 3, and k x to the negative 2, all to the power of 2. Now, what does this give us? This gives us 5 choose 2, which is, that's 10, isn't it? Yeah, 10, times 8, So 80, and then k squared x to the negative 1. Okay, now we know that this is q, so therefore 80 k squared equals q, and since q is 80, 80k squared equals 80, k squared equals 1, so k equals plus or minus 1. And that would be our answer there. That was actually not too bad at all, was it? Okay, well, let's move on. What have we got here? The first, second, and third terms of an arithmetic progression are a 3 over 2a and b respectively. And the first, third, second and third of the geometric are a 18 and b plus 3. We've got to find a and b. Okay, let's start with the arithmetic. We've got a 3 over 2a and b. Now we can see that d in this case is 1/2 of a, because that's the difference, and therefore b is equal to 2a, right? Because it's the difference that we go from first to the second term is we've got 1/2 extra a, and therefore to get to b we must have another half extra a, which means that b must be worth 2a. Okay, so that's fine. Let's have a look at the geometric. The geometric, so a 18 b plus 3. Now since the first, second and third we know that 18 over a should be equal to b plus 3 over 18, because remember this is a, this is ar, and this is ar squared, so ar squared over ar should be equal to ar over a. So we can go 18 squared, which is 324, equals to a into b plus 3. Now at this point we can substitute in what we know b to be so that we can solve for a. So we get 324 equals a into 2a plus 3, and this gives us when we expand, we get 2a squared minus plus 3a and minus 324 equals to 0. At this point we can now factorize like so. I think it was 27 and minus 12, and so a equals negative 27 over 2 or 12, but a and b are positive constants, so we can rule this one out. Therefore b is 24, and we are done. Find the first 20, the sum of the first 20 terms of the arithmetic sequence. So sum of 20 is going to be equal to 20 over 2 bracket 2 times a, well a is 12, so 2 times a is 24, plus n minus 1, which is 19 in this case, times d, which is, what do we say d was? Half of a, right, this bit here, half of a. Now a we said to be 12, so half of 12 is 6. Equals, what does this give us? I get 1,380. I hope that's right. Let me just do a quick check on that. So the 20th term, yes. 2a and we found a to be 12. Double 12 is 24. Plus 19, 20 minus, yep. And then the difference is half of a, which is 6. Yeah, so 24 plus 19 times 6 equals 138 times 10. Yep, 1,380. Perfect. Okay, lovely. So that's the June 1-2 questions. Let's move on to the June 1-3 questions here. Write down the first 4 terms in the sequence. Okay. So we're going to go 6, choose 0, a to the power of 6 times negative x to the power of 0. That's the first one. 6, choose 1, a to the power of 5 minus x to the power of 1. 6, choose 2, a to the power of 4 minus x to the power of 2. And then the last one, 6, choose 3, a to the power of 3 minus x to the power of 3. Okay, perfect. So we just add those all up. The first one, of course, is a to the power of 6. The second one is a minus 6a to the 5x. The next one is going to be 15 a to the 4x squared. And the last one is minus 20 a cubed x to the 3. Okay. The next one, given that the coefficient of x squared in this is 20, find the exact form, the possible constant values of a. That does not sound very nice. Okay. Well, x squared. Okay, so what we're going to do is we're going to go 1 plus 2 a to the negative 1 x to the negative 1, and then we're going to put it against what we've just done here, a to the 6 minus 6a to the 5x plus 15a to the 4x squared minus 20 a cubed x cubed plus blah blah blah, which we don't have. Now we're trying to find the coefficient of x squared, so how are we going to do that? Well, this one times this one could do it, couldn't it? And of course then there's this one times this one. I think there's the only way we can do it. Alright, well let's do that then. So the pink line, what is the pink line going to give us? Negative 40 a squared, because that a to the negative cancels out, negative 1 cancels out one of the a cubed, so it becomes a squared, x squared. And then the other one is just simply plus 15 a to the 4x squared. Now, the coefficient is negative 20. So that means, therefore, negative 40 a squared plus 15 a to the 4 equals negative 20. I would probably turn this into a, what do you call it? A quadratic-y type scenario. Like this. Divide everything out by 5, I think. So we could get 3a to the 4 minus 8a squared plus 4 equals to 0. And I reckon we could go 3a squared and then have a squared here minus 2, so that's negative 6. Yes, okay, and that will give us the negative 8 there that we need. 3a, so negative 6a squared minus 2a squared. Yes. Okay, perfect. So a squared equals 2 over 3 or 2. So a equals plus or minus the square root of 2/3 or plus or minus the square root of 2. That they wanted it to an exact form, so I'll leave it like that. And I think those are the possible values. Lovely. Geometric question. So, geometric progression is such that the second term is equal to 24% of the sum of infinity. Find a possible value of the common ratio. Okay, well, AR, that's the second term, equals 24 over 100 times A over 1 minus R, which is the sum to infinity. Right. Now, probably I could just times everything, both sides by 100. So I could get 100 AR equals 24A over 1 minus R. Now it says the possible values of the common ratio. You can see we've got A on both sides here, so we could just get rid of the A's at this point, couldn't we? So we could have a 100 bracket 1 minus R equals 24, because I've just divided the A's out of both sides because I just want to find the possible values of the common ratio. Yeah, alright. But that should be not. It should be 100 R, shouldn't it? I got rid of my R there as well. So there, and this will give us 100 R minus 100 R squared minus 24 equals 0, and we could just times everything by -1 to get a nice sort of quadratic equation here. Divide everything by 4, so we get 25R squared minus 25R plus 6 equals 0. Factorize, I think we can. What if we go 5R squared, 5R squared, and sixes, so maybe minus 6. No, that's not going to do it, because then we'd be too high. What about minus 3? Minus 3 will give us minus 15 and minus 10, yep, which gives us negative 25. Yep, so that's good. So we get R is equal to 2. Oops, not R squared. What? Wake up. Just doing what I did for the previous question. Okay. Okay, so R is equal to 2/5 or 3/5. The two possible values for the common ratio there. Okay. An arithmetic progression has P has the first term A and the common difference D. Okay. The arithmetic progression Q has the first term 2A plus 1 and common difference D plus 1. It's given that the fifth term of P over the 12th term of Q is 1/3, and okay, and we've got to find the values of A and D. Okay, well, the fifth term of P is A plus 4D. The fifth term of the Q, so the 12th term of Q is going to be, this is our first term, so it's going to be 2 bracket A plus 1. And then we've got to have 11 differences plus 11D plus 1. And this will give us 1/3. Now I'm going to work with this and make it a little bit easier for me. So A plus 4D over, that will give me 2A plus 2 plus 11D plus 11 equals 1/3. And so we can say, what do we end up with here? A plus 4D over 2A plus 11D plus 13 equals 1/3. And then we can cross multiply, so I get 3A plus 12D equals 2A plus 11D plus 13. So if I take the D's across to that side and the A's across to that side, A plus D equals 13. I think that's right. Well, that's nice. Now let's try the next one. The sum of the first 5 terms of P. Oh, the sum. Okay, now we're doing sum. So sum is going to be n over 2, so 5 over 2 into 2 times A plus, whoops, n minus 1, which is 4d. Okay, so that's that one. Now on the bottom, this is where it's going to get complex here. First 5 terms of q is 5 over 2, but this time it's 2a. Now this is a here. That's their first term. So I guess we could just say 2 lots of that, which is 4a plus 4 plus n minus 1, which in this case is 4, and we're going into d, which is d plus 1 in this case. So it wasn't so bad after all. And this is all equal to 2/3. So we're just going to carry on with this nonsense here. Well, hopefully you can see that we can just cancel out the 5 over 2's, right? Like that. So on the top, we're going to have 2a plus 4d. And on the bottom, hopefully you can see we've got 4a plus 4d. Plus 8, I think. Yeah, I think that's right. Is equal to 2 over 3. Now, if we just switch the sides here, so times the 3 by the 2a, so that's 6a, and then by the 4d plus 12d, and then this one goes over to that side. So multiplying that 2 by 4a plus 4d plus 8, so that's 8a plus 8d plus 16. And then we're just going to bring everything across to one side, so we get 4d over there, and actually we'll bring the a's over there, 2a plus 16. And I guess we could divide everything by 2, so 2d equals a plus 8. So a equals 2d minus 8. So this should help us quite a bit actually. Now we can find the value of a and d because we can substitute in. So if a is 2d minus 8, I can substitute that into the first formula, so 2d minus 8, so I'm substituting into here, that's a, and then plus d equals 13. So I get 3d minus 8 equals 13. So 3d is equal to 21. So d is equal to 7. And now I can substitute the d equals to 7 into here. A equals 7. 2 times 7 is 14. 14 take away 8 is 6. So d equals to 6. And I'd say we're done there. So that's all of the series type questions from the June series of exams. Hope that's been helpful to you. Let me know if you have any questions or comments. Alright, take care team. God bless.